great job on your homework. You can go ahead and put your homework away and go ahead and take your books out, and you can go ahead and open them to page 139. We're going to be using our books a lot today, and we have looked at several different things about the past 2 weeks. We've looked at like terms and equations and monomials and exponents. We've looked at a lot of things, and now we're all using them, and we're not even thinking about it being new anymore. We're not thinking, oh, I've never seen that, or I need to brush up on this. We're just rolling right through it, and today we're going to be taking a lot of all of those skills, and we're going to be putting them together into one thing. We're going to be just reviewing everything that we've done and seeing how sharp we are on it, and make sure we can just click right through to get ready for our test that we have tomorrow. So go ahead and turn in your books to page 139, and we have some true-false problems that we're going to start out with. So you're going to get a few minutes to work on your true-false, and we're going to go 1 through 10. Just go ahead and do those at your desk. Make sure you read the problem thoroughly, and you write true or false in the blank. You are working through those. When you get done, you can go ahead and put your pencil down and look up at the board. All right, looks like everybody's finished up with those true and false. We didn't have to do a whole lot of arithmetic or anything solving. So we're just going to go through these, and we're going to go row by row and just see what you got, true or false. So I'm going to read the problem, and then I will call on you to see what answer you got. Make sure you're following along, even if I don't ask you specifically, to see if you got the right answer. So number 1, the exponent for 2x is 1. And what did you get for that? We'll start in this row, Jobin. You said that's true, and he is exactly right. 2x, we know that exponent is 1. What do we call that number? What do we call that? There's a word we use for that, Maya. It's understood. That's right. Anytime we have 2x or anything, if we have y, we know as long as there's nothing above it, we understand it to be 1. Great job on that. Number 2, the number 0 is a natural number. But now we're throwing it way back, and we're getting some numbers that, natural numbers, real numbers, we've been learning about those, but it's been a while since we visited those. So Maya, what did you get for number 2? That 0 is a natural number, and she got false, and she is correct. Number 3, an opening or closing parentheses can be used to indicate multiplication joy. True. That's right. If you all should have true, we've talked about many different ways that we can represent multiplication problems. Raised dots and our parentheses, and then also putting our numbers with our letters. That all indicates multiplication. Number 4, the letter x in x plus 4 has a numerical coefficient of 4. So they're saying that x in x plus 4 is equal, the numerical coefficient is 4. What did you get? Now we're back here in this row. Mark, did you get true or false? You are correct that it is false. What is the numerical coefficient in this? 1. That's right. We understand, once again, that's another understood number. It's understood 1 because we don't have anything there. What is our literal coefficient in this, Jobin? X. That is the literal coefficient. Now we're on number 5. The algebraic expression expression containing two terms is a trinomial. What did you get for that, Kelly? You said that it's true. What did you get for that, Maya? All right, you had false, and it is false. Remember, we count up how many terms, and that's how we know if it's a monomial, binomial, trinomial, or polynomial. So Kelly, you said that it was true, but that had two terms. So what would a two-term polynomial be called? That's right, a binomial. So you just got a little confused there. Great job. Let's look at number 6. In x to the 4th, the base is x. Tiffany, you had true. That's going back to bases and exponents. We know the exponent is the one that is above, that is raised. Number 7, the terms 4xy and 4x squared y are like terms. We're back over here to Jobin. And he said false. Why are those not like terms? Because the x isn't squared. So if we wanted to make that a like term, what is one of the things we could do, Maya? We can have xy, or we can make the other one x squared. That's exactly right. Remember, that's one of those ones I said we want to be able to lay it right on top of the other and get the exact same thing. It looks like it's an exact copy. Number 8, always solve within the parentheses first. Always solve within the parentheses first in an algebraic equation. And you had true for that, Mark. That's right. Why do we always solve parentheses first, Joy? Because of order of operation. So we go through our PEMDAS, and parentheses is the first one that occurs. So that's right, why we would always do our parentheses first. Now we have AB to the 4th divided by AB to the 5th equals 1 over B. Tiffany, did you have true or false? She says true. Let's see if she's correct. I think she's right, but we will see what she had. We had AB to the 4th divided by AB to the 5th. This is one where we have to do a little bit of reconstruction to get it to look like we want it to, equals 1 over B. We have division, so it would be nice if we could just put it over a fraction bar. So that's what we're going to do. We would write AB to the 4th over AB to the 5th is equal, it says, to 1B. Well, since we're dividing, we can go ahead and cancel, and we have the same basis, so we can cancel these. These will cancel. This leaves me 1. So she is correct in that it is 1 over B. Did everybody else have true for that one as well? All right, great job, class. And then the last one, number 10, whatever is done to one side of an equation must be done to the other side. And I hope that everyone put true, because we have said that over and over. Whatever you do to one side, you must do to the other. So great job on that true and false. Let's go ahead and look at complete the chart on 11 through 14. I'm going to give you about a minute or two to work on that. You're just filling in. This is where we have to look at the words they give us. We have to look at the numbers, and we have to see, okay, exactly what are they telling us to do. So go ahead and work on those at your desk, 11 through 14. Julie, you're to be working on the classwork. I'll take this, and you may see me after class. Just a few more seconds as you wrap up 11 through 14. All right, looks like everybody's done. Go ahead and turn your attention over here to the sideboard. And the first one, number 11, they gave you the algebra, and they wanted you to write the English. So we had 3x minus 4. But there's a few ways that if we were reading this along, or we had something where we didn't exactly have it written out in our algebra, how we could come to this conclusion without our algebra. Joy, what did you write down in the blank for English of 3x minus 4? So you said 4 less than 3 times x. Where did you get the less from? Why do we say less, Joy? Because of the minus sign. That's exactly right. Remember, anytime we have a minus sign, we know that it is less than something. And then she had 3 times x because we know that 3x equals 3 times x. The next one was one that I think everyone is very familiar with. B to the 3rd power. And let's answer this one together in the class. How else would we say that in English class? B cubed. That's right. The next one, they gave you 1/2 x plus 5. That's a lot of words. Let's put it together in our algebra to make it where we can just read it and we can solve it or do something with it. 1/2 x plus 5. Your answer should have looked like this. I have my plus sign and I have 5, and then I also have my 1/2 of x. 1/2 x, what operation are we doing here, Jobin? Multiplication. So a lot of times when you see or read or hear the word of, you know that we're probably doing some sort of multiplication. 3/4 of a number, that gives us 3/4 of x. And then the last one, they gave you 3 less than x squared. So you should have had x squared minus 3. There we had our less than, so we put a minus sign, and then we know how to write x squared, just x to the 2nd power. So now we've gone over several of our rules, several things that we have been learning, not necessarily arithmetic things, but things that we can use in our equations, in our terms, to make sure that we're doing everything properly. Let's look at number 15. I have it up here on the board, and it asks us to simplify. What do they mean by simplify, Tiffany? Okay, to make it more simple, to put things together, if it means to divide or to multiply, to make it where it's as short as possible, but it still contains the right answer. So up here, we need to simplify this, but we have a few things that we need to keep in mind whenever we are adding or subtracting terms. And what is that very important rule, Jobin? They have to be like terms. So I'm going to look up here, and then we're going to see what all like terms we have. Maya, what like terms do we have up here? 2x, 5x, and 3x. She's exactly right. Class, do you agree? Because they're all just the same x, we could lay that term right over the other one, and it would be the same. So we can just buzz through here and add them. 2 plus 5, class, plus 3 is 10x. Let's go ahead and look at 16. It has a few more before we practice these. We have 9x squared plus 4ax plus 3x plus 2ax. So we need to find our like terms. What are some like terms that you see, Mark? What are ones that jump out to you that are like terms? Okay, he said we have the x squared and x squared, and then join. So that leaves some left over. What do we have that are other like terms? Okay, we have 4ax and 2ax. So now we know, since we have like terms, we're just going to join them together. So 9 plus 3 is 12x squared, plus 4 plus 2 is 6ax. And everybody agrees that we have to have like terms, and then we just do our arithmetic to get it to this most simple terms. We can't do any more with this, can we, Mark? No, everything, we've joined our like terms. There's nothing more for us to do. Go ahead and work on simplifying those polynomials. Go ahead and work on 17 through 20. Those 4 problems, go ahead and join your like terms. Mark, you can put 17 on the board. Maya, you can put 19 on the board. I'll get this erased for you. The rest of you be working diligently at your desk. Make sure you're working diligently. 14 through 15. Looks like everyone has finished up. We had 17 through 20. So I had 17 and 19 at the board. Maya, you had 17. Go ahead and show us what you did. Does everyone agree with Maya's answer? Okay, we do a great job. Maya, you can go ahead and erase that and have a seat. Number 18, you should have gotten AB plus 3B squared. AB plus 3B squared. On 19, we had Jobin at the board doing number 19. So go ahead and show us what you did there. All right, we had 2x squared plus 5x squared y plus y, 5y squared. Way to catch all the, you had 3 different terms there, Jobin. You caught all of those. Great job. You can erase that and have a seat. And then number 20, we had 8b. Those were all the same. You just had to add or subtract, just go through the line. So you should have had 8b. Great job on that. Make sure you remember you always have to have those like terms, those identical terms if you wish to add them or subtract them. Our next section is dealing with exponents. And I really like exponents. I think they're fun and you can make them long or short. And up here we have 4 times 4 times x times x times x times y times y. That is a mouthful, and we've been talking about how we want to simplify things. We want things to be as simple as possible, and I think you all would agree with me that this isn't as simple as it comes. So what can I do, Joy, to maybe make this a little bit more simple? That's right, 4 times 4 is 16, so we have that taken care of. What can we do with our x's? Jobin, you say add our x's, add the exponents. Why can we add our exponents in this case, Maya? Because they all have the same base. We have x, 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 and we know these are understood ones up here. And because we have the same base, then we can just add. So that would give us x to the what power, Tiffany? X cubed. So the same thing with the next one, Mark. What can we do with our y? We can make it y squared. That's exactly right. So we took this and condensed it into 16 x cubed y squared. There's just 2 of those there, 22 and 23. I'll give you about 30 seconds to work on those and see what you get for 22 and 23. Okay, y'all are done. So 22, you had a lot to work with there, lots of A's and B's, so you should have had 16 A cubed B cubed C. 16 A cubed B cubed C. And then on 23, you should have gotten x to the 7th, x to the 6th. Did everybody have x to the 7th, x to the 6th? Nodding heads. All right. Now, one of my favorite ones is our order of operations, and someone already explained to us why we always do parentheses at the beginning of equations, but that's anytime we have any kind of arithmetic, we can follow our order of operations. And what do we use to remember our order of operations, Tiffany? PEMDAS, that's right. So we have parentheses, exponents. What are the next ones, Mark? Multiplication, division, and then addition and subtraction. So up here I have something that we can do our arithmetic with. We have 6 parentheses, 3 plus 2 minus 5. Well, we have several operations going on up here. We have some addition, we have some subtraction, we have some multiplication, and we also have parentheses. So we're going to go back to our PEMDAS, and we're just going to go down in order. So what is the first thing that we're going to look for, Mark? Parentheses. And do we have parentheses? We do. So we're going to work from inside the parentheses and solve them out. Tiffany, what is the inside of my parentheses going to become? 5. So we should have 6 times 5 minus 5. Everybody agrees with me here? So 6 times 5 minus 5, and we still have parentheses. Yes, Maya? Yes, you may use the restroom. So our 6 times 5, we still have a parentheses, so we're going to go ahead and solve that. What will our next thing be, Joy? All right, 30. 30 minus 5. Well, now we have a simple expression that we can just solve. We don't have to worry about anything because we're not left with any other operations. The only operation left would be Maya, oh, she's in the restroom, would be Jobin minus, that's right, so subtraction, so we'll get 25. We're going to have a little contest here between our rows. We have some expressions 25 and 26. So don't start them yet. That's right, get your pencil ready. You are going to do number 25 and number 26. And you, first person to be done, you will stand when you are done with 25 and 26. We'll see which row can finish up both of these. Go ahead and go. And your answer has to be correct. Okay, Mark was our first one to stand up in our middle row right here. Mark, you will be the one to give us our answer. We'll go ahead and see if we have a second place just in case Mark messed up. Okay, and I see Joy popped up over here. Go ahead and keep working. We're going to have Mark and Joy give us the answer in just a second. All right, it looks like everybody is done. Mark, what did you get for number 25? He got 11. That's exactly what I had. Everybody agrees. Great job. And number 26, what did you get? Let's see if you get all the points if you had 26 right. All right, he had 42, and he's exactly right. Everybody else should have had 42 if you followed your order of operations through. Great job. A way to work on that quickly, and you all seem to have the correct answers as well. The next section is evaluate. And what do we mean when we say evaluate, Jobin? They're going to give us a number, and we're going to put it in. We're going to evaluate it for the number, for the letter that we have. So they said evaluate if x equals 0.1 and if y equals 3. So we'll do 27 together, x squared. But you need to find out what x squared is. And it's a good thing that they told us what x equals. What does x equal, Tiffany? 0.1. So we know that we can just come over here and go oh, I got my decimal in the wrong place. That changes everything. So we had 0.1 squared. So we can go ahead, and if you're not sure, our decimals, sometimes I get a little confused on my decimals. What is the way that we could solve this if we didn't just know it right off? Tiffany? So we can do 0.1 times 0.1 because that's what squared means. So 0.1 times 0.1. 1 times 1 is 1, and we have 2 decimal places. So your final answer should be 0.01. Go ahead and work on 28 and 29 at your desk. We'll go over those very quickly. 28 and 29, just plug it in the numbers that they give you and see what you have. Mark, make sure you keep those feet on the floor. I know the basket is tempting, but we don't want to break our baskets. Working diligently on those just 2 problems. Once you're done, you can look up here this way. It appears that everybody is done. We'll go ahead and go over them. You should have done 28 and 29. 28, what answer did you come with, Tiffany? All right, 8.99. So we're working with those decimals. That is exactly right. That's what I had. Does everybody have 8.99? If not, you might want to check your decimal places or your multiplication. And then 29, you should have gotten 6.3. 6.3. Okay, we're going to go ahead and work on some equations and see how much we remember from our list if we know everything for our checklist for solving these equations. So the first step in solving equations is always to do what, Maya? Simplify. So I have an equation up here, x plus 5 equals 14. That is a raised dot, so 14 times 2. So what can we simplify, Maya? 14 times 2. You are exactly right. So x plus 5, and what is 14 times 2 going to give us, Tiffany? 28. Okay, so we have x plus 5 equals 28. Now we need to identify our unknown. And what is our unknown, Joy? X. That's the only thing we don't know what the value is. So we can go ahead and try to get it alone by doing what, class? The opposites. That's right. What is my opposite operation for this specific equation, Jobin? Subtraction. So we're going to subtract 5 from just this side. So that'll give me 28. There, I did it right. No, you all are shaking your heads. You all know better. We want to do it to both sides. Whatever we do to one side, we must do to the other. So we'll go ahead and subtract 5 from this side to give x equals 28 minus 5 is 23. But am I done? Y'all shaking your heads. No, you're exactly right. We are not quite done. We must check our answer. I say on a test, you should always check your answers if you can to make sure that you're going to get that full credit. So we're going to evaluate, just like we did in the problems before this, we're going to evaluate x at 23 in this equation. So we would have 23 plus 5 equals 14 times 2. Well, now we have a whole lot of simplifying to do. So we'll go ahead and simplify this side, and we get 23 plus 5, class, is 28. And 14 times 2, class, is also 28. So those are identical. They check out, and we did our problem correctly. Let's go ahead and have you work on 40 and 41. Maya, you can do 40 at the board, and Joy, you can do 41 at the board. We'll go over these problems. Make sure that you check your answers. These two problems, working diligently. You all have focused very well. Okay, 40 and 41. Joy, you're done with 40. Go ahead and tell us what you got, how you got it. And she checked her answer 5 to see that 15 equals 15, and she did that exactly right. Make sure your paper matches her work at the board. You can erase that. Thank you, Joy. Maya, what did you have on 41? X equals 48. That's what my work checked out to be. Great job. You can have a seat. Make sure you erase that and have a seat. We did a lot of practice today, and that's because we have a test coming up. So tonight your homework is 1 through 12 sharpening skills, and you need to study for test 4. So we did some great practice today, so go over those problems. If there's any you weren't quite sure of, make sure you practice those so you'll be ready for our test tomorrow. You are dismissed.